Section 11.1 is on the circle vocabulary and tangents. Our learning standard for today is that you can understand and apply theorems about relationships with line segments and circles, including radii, diameters, secants, tangents, and chords. Okay, so if you're watching the video, you can skip the part where we're going to team up, and we're just going to start by talking about these things. If you want to take a minute and try to fill them in ahead of time to see how much you know, you can do that as well. So the first part is, what is a circle? And a circle is all of the points that are equal distance from a center. All right, so if we have a circle here, I'm going to use the tool so I can get a nice circle. This represents all of the points that are the same distance from the center of the circle. So that point here is the center. Okay. So then next we have a radius, which is a segment that goes from the center to the edge of the circle. Okay, so then that would look like this. And it can go in any direction as long as the endpoints of the segment are on the center and then the edge of the circle. Next, we have a diameter, which is again a segment that goes all the way across the circle. And it has to go through the center. And that would be a diameter. So if we draw an example here, it goes through the center and connects the opposite sides of the circle. And then the center is just the point in the middle. Hopefully these are all vocabulary that you have seen before and they're not new to you, and that'll help make the rest a little bit easier. So then next, our new vocabulary. First we have a secant, and a secant is a line that intersects a circle at 2 points. So for this one, another thing that we can add, it doesn't have to be just a line, it could also be an object. The key thing is that it goes outside of the circle. And that's the key difference. And one thing to remember is a line continues in both directions forever. And if we were to draw an example at our circle up here, it can be anywhere on the circle as long as it intersects the circle at 2 points. There we go. So that would be an example of a secant. Next, we have the vocabulary word of a chord, and this is a segment whose endpoints are on a circle. And a segment is a line that has 2 endpoints. So it's just part of a line, not the whole thing. And if we were to draw an example of a chord on our circle, we would just have 2 points anywhere on the circle and then connect them. The difference between a chord and a secant is a chord is only in the circle and a secant goes outside of the circle as well. And our last vocabulary word is a tangent, and this is a line in the plane of the circle that intersects the circle at exactly 1 point. And another vocabulary word you need to know is a point of tangency. And a point is just a dot. And if we were to draw this on our circle, we can put a point there and draw our tangent. So this line only touches the circle at one point. So this line segment, or the line, would be called the tangent. And then this yellow point here is the point of tangency. All of this vocabulary is really important. There is a section on the quiz and also on the test. So make sure you are reviewing this and studying it all the time, and you know the difference between the different terms. All right, so next, example 1. We're going to use the diagram to tell whether the line, ray, or segment is best described as a radius, chord, diameter, secant, or tangent. So the first one is segment AC. So because that only takes up half the circle, that is going to be a radius. Next we have segment AB, and this goes across the circle and through the center, so that one is going to be a diameter. Then we have ray DE. And you'll notice, I know it doesn't draw that there, but this line only touches the circle at one point. So this one is going to be a tangent. And last we have line AE, which would be this line going diagonal. And that one is a secant. And that gives us all of the answers for example 1. And being able to do problems like this are important. There will be one on the first quiz. Okay, and next we have coplanar circles. There we go. Let's see. Oh, sorry, my iPad is not working very well right now. Let's see. Sorry about that. Let's try this again. There we go. Now it's letting me scroll. Okay, so next we have our coplanar circles. And this is two circles can intersect at 2 points, like the first example, 1 point, or at no points. And when this happens, we will have something called common tangents sometimes. And common tangents are just lines that meet up with both circles at exactly 1 point. So if we do an example 2, they want us to tell how many common tangents the circles have and draw them. So if we look at the first one, we can put a point on the top of both of the circles and draw a tangent there. We can do the same thing with the bottom of the circles, drawing a second tangent. And we can draw one going through the middle. And same thing going the other direction. So this one is going to have a total of 4 common tangents. If we look at our second example, we would have one that goes right through the middle because these two circles are tangent. And then, just like our previous one, we can draw one on top and one on the bottom. So this one is going to have a total of 3 common tangents. And lastly, we have our third example. And this one is only going to have 2 common tangents. And the reason is because we can't draw one in the middle because those lines wouldn't be tangent because they would cross the circles more than once. Okay, so that's how we can tell if we have common tangents. Next, we have tangents in a plane. And a line is a tangent to a circle if and only if the line is perpendicular to a radius of the circle at its endpoint. So anytime you have a tangent drawn and a radius connected to that tangent, that is going to form a right angle. Knowing that information, we can complete example 3. So in the diagram, PT is a radius of circle P, and they want us to figure out if ST is tangent to circle P. If ST is tangent, that would mean this is a right angle, making a right triangle. So we want to show that it works or doesn't work. So we're going to use Pythagorean theorem. Remember, C is always opposite of the 90-degree angle, and A and B are just the two legs of the right triangle. So we can do 12 squared plus 35 squared equals 37 squared. And we want to make sure that this is true. So we'll grab our calculators and just type this in to see what we get. 12 squared. Oh, my iPad is not very happy today. All right, so 12 squared plus 35 squared. That is going to give us 1,369. Okay, and if we check what 37 squared equals, and we end up with the same thing. So our answer is ST is tangent to circle P. And that's our answer. If they were not equal, then it would not be tangent. So it has to form that right triangle or that right angle if it's going to be tangent. Now, looking at example 4, in the diagram, they told us that B is a point of tangency, which means that this is a right triangle. So again, just like the last one, we are going to use Pythagorean theorem. So for this, I recommend identifying A, B, and C first before you plug anything in. So A can be R and B can be 80. C, remember, is the whole length of the hypotenuse. So that is going to be 50 plus R. And because we're adding, we're going to make sure we put it in parentheses. So if we plug this into Pythagorean theorem, we would have R squared plus 80 squared equals 50 plus R in parentheses squared. And if we simplify, remember that when you have parentheses squared, this really means we're taking this multiplied by itself. So we are going to have to FOIL here. Once you've FOILed, you can start combining your like terms. So we can add these two 50 R's together. So we'll have R squared plus 6,400 equals 2,500 plus 100R plus R squared. Looking at this equation, you might notice that you have an R squared on both sides of the equal sign. So we can just subtract that, and we no longer have an R squared. And our goal is to get R by itself, so we're going to also subtract the 2,500. And when we do that, we are going to end up with 500, 3,900 equals 100R. And if we take our answer and divide by 100, we get R is equal to 39, which is our final answer. And our last example for today is going to be talking about two tangents to a circle. And when tangent segments from a common external point are both tangent to the same circle, that means that these segments are going to be congruent to each other. So in this one, ST is going to be congruent to RS. And that's only true if they're tangent and they come from the same starting point. Using that information, we can do example 5. So RS is tangent to circle C, RT is also tangent. So because they both come from angle R, we know that 28 has to be equal to the 3x plus 4. And we can go ahead and solve this equation. Subtract 4 on both sides, and we get 24 equals 3x. And lastly, we're going to divide both sides by 3. And when we do that, we get x is equal to 8. And that's our final answer. So if you have any questions on the homework, just let me know. Don't forget to check your answers with the key that is posted on Schoology.